Now we are going to repeat the same sampling layout steps that we did in the previous video, this time using Model Builder. Model Builder will allow us to repeat the analysis using different parameters with just a few clicks, rather than starting over from the beginning. First, let's review the progression of steps. First, we buffer the ponds, creating a 50-foot band around each one. We then clip the streams to that buffered area, identifying those portions of the stream that flow into or out of a pond. Next, we buffer those sections of stream by 50 feet, creating potential sampling areas. Some of these will overlap with the ponds, and we're going to use the ponds to erase those overlapping areas. Next, we're going to clip the resulting layer to the original 50-foot buffer around each pond, and that will leave us with those areas that are within 50 feet of a pond and within 50 feet of a stream. Finally, we're going to generate random points within this potential sampling area, and these will be the points that we navigate to in the field to collect data. To begin working with Model Builder, you'll need to have access to both the catalog and the search bars on the side here. First, open Catalog and navigate to your working folder. You need to right-click on a folder and say New, Toolbox. The toolbox is what the model lives inside. Next, right-click on Toolbox and say New, Model. This is the model editing window. To bring data into this window, we need to click, hold, drag, and release. Repeat, click, hold, drag, release. Now we have our ponds and our streams. In order to apply a tool to these data, we need to first search for the tool. We're going to start with buffer. If we click and drag buffer into the window, here's our tool. The tool is hollow, meaning it does not have what it needs to run. It needs data first, so we can use the connect tool from the toolbar up here. We first click and release on ponds, and then click and release on buffer, allowing us to set that as the input feature. The tool is still hollow, meaning that it needs more information to run, so we double click on that, and this green dot indicates where the information is required. We're going to specify a distance of 50 feet. We are also going to set the side type to outside only, and the dissolve type to all. Okay. Now this has not run. This is just ready to run. To run something in Model Builder, we just need to hit the little blue triangle here that says Run. It has completed, and by default it does not display because this is going to be an intermediate step. We can say Add to Display, and there it is. If we say Model, delete intermediate data, it did nothing. And now it's gone. Alright, so our next step is to clip the streams to this buffer area. So we search for the tool Clip, and we drag that tool into the Model Builder. There it is. So we connect our streams data to the clip tool as the input feature, and we connect our buffer output to the clip tool as the clip feature. Now that's complete and ready to go, but this is starting to get disorganized. So we're going to use the auto layout tool, which will put things in the order in which they are used. Now we can again check this box that says Add to Display, run the model, goes through the steps in turn, and now we have a new layer that is only those portions of the stream that are within 50 feet of a pond. Now to continue on with our analysis, we can remove that from our display, and now our next step is to create a buffer around each one of those stream segments. So we're going to search for tools again, search for buffer, drag that tool into our Model Builder, connect the data to the tool as an input feature. Again, it's hollow, meaning it needs more data. We will give it the information it needs, which is a distance of 50 feet, and we want the dissolve type to be all, which means each one of these different pieces that is buffered will be put into a single feature, and that will allow us to distribute points within that one single feature. Okay, good. Now, that buffer will again overlap with the pawns, and we're going to use the pawns as an erase feature to get rid of that area. So search for tool erase, drag that tool in, and connect that output to the tool as the input feature, and the pawns are going to be our erase feature. We're going to use auto layout again to organize this, and we can use full extent to show all our work so far. And we're going to save. Next, we want to have this potential sampling area clipped to this original pawns buffer, so that we have only those areas that were within 50 feet of both the pond and the stream. So we're going to search for tools, clip. We're going to drag that tool in. We set this output as the input feature, and our ponds buffer as the clip feature. And we can again use the auto layout and full extent to show our work so far. Finally, we need to create our random points. So search for tools, create random points. Drag that tool in. And this default geodatabase is just where this data is going to live when it's done. So we need to connect this output to the tool as the constraining feature class. It has remained hollow, indicating it needs more information. Double click, and it wants a name, so this is going to be our, I'm going to call it sampling points 30, and this time we're going to create 30 sampling points. Okay, and now this is all ready to run. We're going to hit save. We're going to check the layout, see the full extent. So we are going to take our ponds data, buffer them, and then clip the streams to those data. The stream sections are then going to be buffered. Those portions of the buffer that overlap with ponds are going to be erased, and then we are going to clip that output to the original ponds buffer. We are then going to create those random points within our potential sampling area and then navigate to those in the field. You can shrink that down, and we are going to say that we want to have that added to our display, and that is the potential sampling area, and we want to have the final sampling points added to the display. So now we can say run the model, and it will go through each step in turn, finally creating 30 randomly distributed points which we can navigate to in the field. But wait, what if we check our statistical power analysis and say, no, we actually needed 40 points? Rather than starting over and repeating this whole process, we can double click on our tool, create random points, and we want this to be 40 points. We're going to call it sampling points 40, and now we are going to rerun the entire model. It will go through each step in turn, and now it will create a new random distribution of points that this time includes 40. Now let's remove both of those. Let's say that we spoke to some expert in the field and 50 feet is really not quite enough. For the sampling distance, we've found the same habitat 100 feet away. We're now going to change both of our buffer distances to 100 feet. So first the ponds, and this is going to be 100 feet. And now the second buffer is also going to be 100 feet. So now we can rerun the entire model. We'll go through each step in turn with the new parameters and generate new outputs. We have 40 new randomly distributed points. They are within buffered areas that are now 100 feet from every pond and 100 feet from any stream. We can change any parameter in this way that we choose. So let's say we just got a phone call that it has to be within 100 feet of the pond, but it has to be within 75 feet of the stream. Okay, we have streams clip. Change that. Now we want 75 feet. Okay. Model. Run entire model. Goes through the entire process again. And within seconds, we've changed the parameters. We've rerun the analysis, and we have new points to navigate to in the field. Now, we'll save this model. And if we come back to this later and decide we want to change something else, we go back to our catalog, go to the toolbox, right-click on the model, and we don't want open, we want edit. And that will bring us back to where we can again change this. So we want 75 feet again on each one of these. Rerun the entire model. And here are our new sampling points within boundaries defined by our new parameters.